we've started recording. So there's two examples I wanted to go through to start. These are both series, which means we're adding stuff up. So we've got a sequence of numbers and we're adding them up. The first one is as follows. It just says evaluate 2 plus 5 plus 8 plus 11 plus some bunch of numbers, we don't know how many or what they are, plus 98 at the end. So we've got some term at the end, but we don't know which term it is. And we want to try and add all these up. So we got T1, that's term 1, term 2, term 3, term 4, and this is term N. It's the last term, but we don't know what the term number is. So in order to add things together, we can say, oh yeah, let's recall what our formula is for adding things together. There's one for geometric and one for arithmetic. So before we know which formula we would use to add these up, we need to figure out if this is geometric or arithmetic. So kind of a quick way to do it is just to, the normal way we do it, right, is we subtract things. So let's go term 4 minus term 3. That's going to be 11 minus 8. That's 3. And term 3 minus term 2. That's 8 minus 5. That's also 3. So it looks like we have an arithmetic sequence. It's got a common difference. It's going up by 3 each time. You might have just looked at it and said, up 3, up 3, up 3. Okay, arithmetic. And that's okay. That's a totally fine and good way to do it. So I'm going to grab these and I'm going to park them over here. And we'll say, all right, that tells us it's common difference, tells us it's arithmetic. Common diff, therefore arithmetic. Okay, so our formula for getting an arithmetic series is the sum of all the numbers is the number of terms times 2 times the first term plus number of terms minus 1 times the common difference, and all of that is over 2. That's one of the formulas we had for adding up all the numbers in an arithmetic sequence. We call that an arithmetic series. There was another one though. The other way to do it, and I'll just put it over here, I'll say or. We had another version of that formula, and that was the first term plus the last term, or you can think of it as the general term, over 2. That's kind of like the two ways that we might do it, right? So that's our formula. So we need to decide, like, what have we got? What do we need and what have we got? Well, we know the common difference, right? Common difference D is 3. So that's one thing we've got. We know the first term, you can call it A or T1, whichever you prefer, is 2, because I can see that's the first term right there. So we have those two pieces. The thing that we're missing is our term number. I don't know how many terms there are in this. That 98, is it the like 15th term, the 30th term, the 100th term? I don't know. I'm going to have to figure that out. So how do I figure that out? I need to use my general term. I need to use my general term. Now my general term for an arithmetic sequence, let me just clear myself a little space here. My general term for an arithmetic sequence looks like this. And it says, okay, to find any number, you take the first number and you add number of terms minus 1 times the common difference. That's my like general term formula for an arithmetic series. Let's sub in the stuff that we know. First term is 2. Common difference is 3. Now let's simplify this. We got to multiply our 3 by everything in the brackets. Three times n is 3n. 3 times -1 is -3. Let's collect our like terms together. So we've got 3n there, and our +2 and our -3 give us -1. So that's our general term. That means I could get any number in my sequence using that general term. But the question is, again, still, which term is 98? I don't know. I need to find that out. But we can actually use this to figure it out. Let's put the 98, and I'm going to switch colors to make this a little obvious that I'm starting something new here. Let's put the 98 right in here. And let's solve for n. That'll tell us which term number it is. So we'll plug in our 98, and we'll find out which term number it is. And I'm going to write that up here. I'm going to say find out which term number is 98. So now we need to solve for n. Let's add 1 to both sides. That'll get rid of that 1 on the right-hand side and leave us with 99 equals 3n. And let's divide both sides by 3. That'll leave us with just an n here, and 99 divided by 3 is 33. And so we can say, so 98 is the 33rd term. So let's put that up here at the top. We can get rid of that question mark, and we can put in a 33. There's 33 terms. Okay, so I'm actually ready to go to use one of my formulas to add these up. Now I could use either one. I could use either one. The one on the left or the one on the right, I could use either one. They're both going to give me the same answer. To me, it looks like using the one on the right is probably going to be a bit easier, a bit quicker. So that's what I'm going to do. So I'm going to say the sum of all the terms is equal to n, which we now know is 33, times the first term, which is 2, plus our 33rd term, because we're putting in a 33 anywhere there's an n. Our 33rd term is 98. It's our last term, divided by 2. And if we work all that out, brackets first, 2 plus 98 is 100. 33 times 100 is 3,300. Divided by 2 is 1,650. And we can say nice therefore statement. Therefore, the sum is 1,650. So what we had to do when we looked at this problem was first identify, is it arithmetic or geometric? We did that. Once we did that, we said, what do we know? We know the common difference, we know the first term, we need to know what the last term is, where we end up. We used the general term to help us figure out which term 98 was. It turns out it was the 33rd one in that big long list of numbers. And now that we knew that it was the 33rd term, we could use one of our formulas to add all that stuff up. We could have chosen either formula. I chose to use the one on the right because it was a little quicker. Okay. Tricky. What if I gave you something similar, though, that was a geometric series? So same kind of question, but a geometric series. Let's have a look. So this one actually tells you it's a geometric series. You could have figured it out by finding the common difference. But this one is tricky because the signs are alternating. It's 15 minus 45. Really, that's plus negative 45, but we can just write it as minus. 15 minus 45 plus 135 minus 405. So it looks like it's alternating positives and negatives. And we have to add all that up. We know it's geometric, so we know we're looking for a common ratio. So let's see if we can figure that out. We're going to take our fourth term. My fours always turn out funny. And divide it by our third term. Our fourth term is negative 405 over 135. And that's negative 3. Our third term divided by our second term is 135 divided by negative 45. That's also negative 3. So it looks like our R value, our common ratio, is negative 3. It's getting multiplied by 3 each time, but the sign is flipping, which means it's actually getting multiplied by negative 3. So let's see what we know. We know our starting term. We could also call that term 1. It's 15. We know our, sorry, not our D. That would be our common difference. We know our common ratio is negative 3. And we don't actually know our number of terms. I'm not sure. So I'll put a big question mark there. No idea. So what term is negative 32,805? I don't know. I don't know. Let's use our general term formula to help us out. Our general term formula for this type of geometric sequence is the first term times the common ratio to the power n minus 1. Let's put what we know in. We know our first term is 15. We know our common ratio is negative 3. And that's the power n minus 1. Let's figure out which term our last one is. So let's sub in. I'm going to change colors here. Okay, so we're going to sub negative 32,805 into our general term. And we're going to try and solve for n. Now Dasha is the only one who's done logarithms. Dasha, if you want to use logarithms for this, you have my full support. I'm going to divide both sides by 15 to try and get n by itself. So negative 32,805 divided by 15 is going to be negative 2,187. Now at this point, we're going to do a little guess and check. We're going to try and guess what value, what exponent to negative 3 gives us 2,187. So let's just try a few. I'm going to go guess and check. And as of right now, this is the only way that you're going to be able to do this until you learn this thing called logarithms. I got a question, so I'm just going to check that before we continue. Dash, you said you did it online and you don't remember it well. Okay, no worries. Then you're in the same boat as everybody else. That's all good. So let's just try some. I don't know. Let's try -3 to the 5. I bet that's close. That gives me -243. Okay, so too low. Let's try a higher number. Let's try -3 to the... I know it's got to be an odd number, like 1, 3, 5, 7, 9, because it gives me a negative answer, which means that the negatives can't all cancel out. So let's try 7. Let's try -3 to the power 7 and see what we get. Oh, that's it. 2187. Check mark. So that means what we've got is we've got to have that 7. It's got to equal n minus 1, right? Because that's the exponent right up here. We've got to have a 7 there to get that to work out. So n minus 1 has got to be 7. So n has got to be 8. So we have to have term number 8. Term number 8 is that one. So we figured it out. And we can say it's term number 8. Now you could have done a brute force method where you just looked at your number list and went times -3, times -3, times -3, times -3. And you would find that you started at your first number and then you had to do that 7 times to get you to your 8th term. And that would have got you to negative 32,805 using your general term. So we say, okay, that's going to be term number 8. We figured it out. Okay, now we're going to use our formula to add them all up. So our sum formula for geometric, that was back here. It's second one from the top on the right-hand side. So this is what we covered yesterday. So the sum of a geometric series is the first term times the common ratio to the power of the number of terms minus 1, and all that is over the common ratio minus 1. Let's plug in our numbers. The first term is 15. I'm actually going to use square brackets for this because it'll make it a little clearer, I think. Pro tip for math, you can use square brackets whenever you want, as long as it makes things a little clearer for you. Okay, so I've subbed everything in. For my first term, I put a 15. For my common ratio, I put a -3. And for my number of terms that I'm adding up, I put an 8 because it's the 8th term. Now we got to simplify this a little bit. So -3 to the power 8, if I plug that into my calculator, I get 6561. And it's a positive number because I multiplied -3 by itself 8 times. So that's 4 pairs of -3. So the negatives all cancel out. So I should expect a positive number. And -3 minus 1, that's -4. Continuing on, let's keep doing our simplifying. 6561 minus 1 is 6560. And now if I work all this out, at this point we're good. 15 times 6560 divided by -4. I'm going to end up with 98,400. over negative 4. Thanks for letting me know, Case. I just saw your message. I appreciate that. Negative 24,600. So you add up all the numbers, they're alternating positive and negative. But it turns out the last one we did, the biggest one, was negative. And so that's going to dominate it, and we're actually going to end up with a negative amount when we add them all up. And we'll say, therefore, the sum is negative 24,600. So those are tough. I wanted to go through these two questions because there's so many moving parts. You need to recognize if it's arithmetic or geometric. You need to figure out what you know and what you don't know. You need to use the general term to figure out which term number is the last one. And once you know which term number is the last one, then you can use that to use your sum formula. That's a lot of moving parts. That's quite complex. And so I wanted to show you an example of each, because these are types where it's a pretty high level question. It includes a lot of different moving parts and a lot of different things we've done in this unit to be able to figure it out. Okay, I'm going to stop our recording.